So you remove log in the numerator, you go to the denominator, isn't it? So denominator, you remove log outside, what do we have inside? 5 raised to power. When they simplify log
625,
yes,
minus log 25 plus log 125 plus log 625 minus a half log 25
minus a half log
25.
You'll be able to simplify. That is a problem on indices and logarithms, isn't it? Now, to simplify a logarithmic expression, the first thing you do is to factorize. The first step to do to simplify a logarithmic expression is to factorize. So you bracket what you want to factorize. 625, 25, 5, 125, 625, 25. So start factorizing. So we have log 625 is 5 raised to power 4. Then minus log 25 is 5 squared, isn't it? Then plus a half log 5 all over log 125. 125 is 5 cube, isn't it? Then plus log 625 is 5 raised to power 4 minus a half log 25 is 5 squared. So the first step is to factorize, isn't it? The next step is to get rid of the coefficient, because for us to simplify it means we are going to remove the logs, isn't it? So for us to remove the logs, we must not have the coefficients, isn't it? So the coefficients of logs are the powers, isn't it? Coefficients of the logs are the power. So you can see the numerator, we have the last term, a half log 5. So it means this a half becomes the power, isn't it? So it is log 5 raised to power half, isn't it? Then the next here in the denominator, the last term in the numerator is minus half log 5 squared. So this a half, which is the coefficient, becomes the power. Are you seeing that? Laws of logarithms, isn't it? The coefficient is that? It's the power. So you got rid of the coefficient. So the first step you factorize, the second step you get rid of the coefficient, isn't it? Then the third step, you join those powers using laws of indices, isn't it? So laws of indices, if you have a case like a raised to power x, b raised to power y outside, it is ax, y. The power outside multiplies with the power inside, isn't it? Laws of indices. And any number without a power is power 1. So if you want to simplify in the numerator, the last term, you can see there we have 5 raised to power 1 inside. 5 is just 5 raised to power 1, isn't it? Then here we have 5 raised to power 2, then a half outside. So you use the laws of indices. The power outside multiplies with the power inside. So it means in the next line we have in the numerator log 5 raised to power 4 minus log 5 raised to power 2 plus log 5 raised to power half. So a half times 1 is, you simplify with the laws of indices, isn't it? Are we together there? Isn't it? Yes. Then in the denominator we have log 5 cubed plus log 5 raised to power 4 minus log 5. You simplify because a half times 2 is what? 1. Is 1. So you have log 5 raised to power 1, not just log 5, isn't it? The power outside multiplies with the power inside. Laws of indices. We are simplifying what is inside the log, isn't it? Good. Having done that, you now remove the logarithms, isn't it? You remove the logarithms. From laws of indices, you say the problem you derived, in fact you derived that the problem must obey the laws of indices for you to introduce logarithm, isn't it? Meaning, if you have xy, if you introduce log, the log can only go inside xy if there's either multiplication or division sign, because that is when the laws of indices hold, isn't it? So when you take log inside, multiplication changes to addition, isn't it? So you end up with log x plus log y. And if you have log x over y, if you take log inside, division changes to subtraction, so that you end up with log x minus log y, isn't it? So it means the laws of logarithms only apply in problems where the laws of indices hold, isn't it? So it means it is like we introduce log inside, and where there is subtraction, it means there was division, isn't it? And where there is addition, it means there was multiplication, so we remove the log outside. So it means when we remove the logarithm, we go back to the original problem, isn't it? Because it is the original problem, you are taking the log inside, then division, then multiplication changes to addition. Are you seeing that? So it means when we remove the logs outside, then we are going back to the original problem, which was having either division or multiplication sign, isn't it? So start with the numerator, you can see same base all through. All of them are to same base. So if the logarithm does not have a base, it is to base 10, isn't it?
Yes.
So numerator, you remove log outside here, we'll have 5 raised to power 4. When you see subtraction, it means it was division, isn't it? Are you seeing that?
Yes.
Then if you see addition, it means it was multiplication. So you remove log in the numerator, you go to the denominator, isn't it? So denominator, you remove log outside, what do we have inside? 5 raised to power. When there's addition, it means there was multiplication, isn't it? When there's subtraction, it means there was division, like that, isn't it? So you simplify what is inside the bracket, isn't it? Before you go outside the bracket, you simplify what is inside there. So if you see what is inside the bracket, it is obeying the laws of indices, isn't it? Same base, isn't it? So same base, when there's multiplication, you add the powers. When there's division, you subtract the powers, laws of indices, isn't it? So simplify inside the bracket, we have log. So inside bracket here in the numerator, the same base is 5, isn't it? Are we together? We are simplifying inside the bracket. We are not interested in whatever is outside, isn't it? So here we have 4. If there is multiplication, it means you add. If there is division, it means you subtract. Are you seeing that? So you use the laws of indices to simplify what is inside, isn't it? Then you go, you do the same with the numerator, go inside the bracket. We want to simplify what is inside. What is outside is none of our business. We are still interested with the bottom mass inside the bracket first, isn't it?
Yes.
So what do we have here? Same base. When there is multiplication, you add the powers, isn't it? Where there is division, you subtract laws of indices, isn't it? So having done that, so what do you have? You have in the numerator, we have log 5 raised to power 4 plus a half minus 2. 2 and a half. 2 and a half is the same as 5 over 2, isn't it? So we have log 5 raised to power 5 over 2, isn't it? Then in the denominator, we have log 5 raised to power 3 plus 4 minus 1, 6, isn't it? So you can see the power, now you simplify, the power goes back to be the coefficient, isn't it? Are we together? The power of the log is the coefficient. So remember, inside 5 raised to power 5 over 2 is the same as 5, then 5 over 2 outside the bracket, isn't it? Because this is like 5 raised to power 1, isn't it? The power outside multiplies with the power. Same to here, 5 raised to power 6 is 5 raised to power 1, then we have 6 outside, isn't it? So you see this power now becomes the coefficient, so that we remain with the log 5 over log 5, which cancels out. Are you see? So it means here we now have 5 over 2 is the coefficient, then log 5 over 6, which is the power, goes to become the coefficient, isn't it? So it is over 6 log 5. So you can see log 5 is the same with the log 5. That one cancels out, isn't it? So you remain with 5 over 2 divided by 6, which is 5 over 2 times 1 over 6, isn't it? You get 5 over 12. So 5 over 2 divided by 6 is the same as 5 over 2 times 1 over 6. So you end up with 5 over 12. And you've simplified a logarithmic expression.